Hey everybody, welcome to another Idea Center tutorial video. In today's video, we're going to be covering how to get your first project started on the CNC router. So we're going to be using some material here to make a sample project, and we will be going through every step in the process from setting it up, creating a design, choosing the correct bit, and actually starting the job. To start, I want to take a look at the setup. So I've got my computer with Easel set up from the startup video. My CNC router is ready to go. There's nothing in it. There is a bit, but we will be changing that out later. I have my material and my notepad, my computer, just to kind of help me get set up if I need to check on anything, but you don't really need those. So the first thing we're going to do is actually take our material, and we need to measure this. So I'm going to come over here, I'm going to grab a measuring tape and calipers. So measuring tape and calipers, and I have a pencil already, so we're good to go. All right, so we're over here at the workstation. I've got my calipers, my measuring tape, and my pencil. And I want to record the width, the depth, and the thickness. So let's take a look at this. We're looking at 12 inches wide. You can see it's not a straight cut here. If I go across the top, it's not perfectly straight, but it is pretty close. We're gonna call this one 6 3/4. And then now we need to measure our thickness. If you're not sure how to use calipers, these are called dial calipers. There's plenty of videos online. We may even put one out in the future for how to use them. But I'm basically just gonna open up the jaws, close it, and read is the number that I'm reading here, 0.792. So we're gonna call this 0.792 thick. All right, so I'm looking at my notes on the wood, and we're gonna input that straight into Easel. Our width is gonna be 12 inches. Our length, I called it depth earlier, but it's length here, is 6.75 inches. And our thickness is 0.792. And if I really wanted to, I can also actually round this up to 0.8. So I'm just gonna go ahead and do that. So now you can see that the shape of this white grid area has actually changed to reflect the shape and size of our material. At this point, I also wanna make sure that I'm using the correct wood type. So looking at our material, this is not a plywood, this is a solid board of something. So I'm gonna see if under the settings we have any options for something like that. I don't believe it's a pine board, but it does look to be soft maple, so I'm gonna choose that. And the only real difference that makes is under our cut settings. You can see there's these numbers, basically telling the machine how fast we can cut. If we have a harder material, a harder wood, or even a metal, it's going to be a lot lower because you have to move slower through hard materials. But if I change it, you can see that. So let's do aluminum. And look at that, 5 feed rate. And if I go back, we are back to 28 inches a minute. That's the speed. Okay, so now that we have our material set up, we can actually get into designing. So I'm just going to go ahead and throw together a quick little design. We're going to speed through it. If you want to learn how to design in Easel, you can check out some other videos online. We'll add those to the playlist soon. All right, so with a pretty basic design completed, I've got a bunch of different elements here. Let's just go through it really quick before we move on. So I dropped in some text elements that can be done with the text tool right here. These are all just basic shapes. All of these are squares. I'm actually going to turn this one into a circle just to show that we're not just doing squares. We can do any shape we want. There are even ways to drop in your own shape. So if you make a drawing, you can add them in, but here I am, I'm just gonna add a circle, make it a little bit smaller. And essentially, there are a couple things we can control. So again, all of this, these are all just basic shapes. This is text. So you'll notice that some are darker than others. The darkest shapes, if we go to the cut tab, are the deepest. So this one is going all the way down to the very bottom of the board. These lighter ones, I think this is about the lightest. These only go down, for example, this far. So this is 0.14066 inches. So it's not really going down very far at all. And if we look at the simulation window on the right, we can see that it doesn't quite go as deep as the darker pieces. So now that we kind of understand that, let's also look at this. So there are different types. We've looked at the cut depth. Now I want to look at the cut path. So this, if we look here on the right, again at the simulation, this is a clear out a pocket cut path. So what this is going to do is it's going to take your end mill on the CNC router, and it's going to use it to get rid of all of the wood inside of this shape. And the shape is defined, again, just as like the square that we dropped in. And we have that same square over here. And if we look at it, it's this outside edge right here. And what we're doing with this one instead is actually telling it to cut inside the shape path. So we have a square path that we're cutting inside of, and it is going to be clearing out a little square border that will leave a basic kind of cookie cutout on the inside. So this is really useful if you want to cut shapes out of material. Like if I wanted to turn this into a fish, maybe I could cut a fish out of the entire board. This is just an example, so I'm just cutting out this little square. And then of course, the clear out a pocket cut path is really useful if you just want to get rid of everything inside of a shape. Maybe if I wanted to take a fish and like press it just slightly down into the board. So that is cut depth, cut path, and one more thing to note about the cut path is that if you're looking at the inside shape path or any of the other ones, so there's on shape path where you can see it kind of goes directly on top of the line. There is cut outside shape path where it will put the end mill on the outside of your shape, and then the one we're using here, cut inside. There are also these yellow circles that you can move around. These are called tabs. And what tabs do is they allow you to keep this center piece, we call it a puck that gets cut out, connected to the rest of your material. Because if you don't, there's a chance that it could come loose. And if it gets caught up by the end mill while the CNC router is going, it'll rip things apart. So we want to make sure that this doesn't get loose. So we've got two tabs here. By default, your tabs should be, to be extra safe, we do 0.2 inches tall and 0.25 inches, a quarter inch wide, and we have 4 of them. And 4, I would say, is just about the minimum for whatever it is you're doing, whatever it might be. You want at least 4 tabs. But yeah, that's basically it. Again, if you want a more detailed dive into Easel, go check out another video on YouTube, either from us or from anyone else. But for now, we're going to keep moving on. All right, so with a pretty basic design set up on the computer, the next thing we want to do is take our material and load it into the CNC router. Essentially, the most important thing is to make sure that this is held on really well to the machine. If it's not, and it moves around while we're trying to cut it, you're not going to get the design you want, and you could also even damage the machine itself. So let's get into that. So first things first, for this project in particular, we're going to be using the tape method for our work holding. Work holding is what we call basically the entire process of attaching our material to the machine. So to start with the tape method, I want to cut a couple pieces of this double-sided tape so that I can attach them underneath our panel. And typically it's standard to do 1, 2, 3, 4, 5 in the center if it's a smaller piece, or 5, 6 if it's larger. This one is a bit bigger, so I'm going to do 1, 2, 3, 4, 5, 6. It's also standard to be cutting around 1 inch to 1.5 inch piece each time. You don't want to waste too much of this material because this stuff is really expensive. So with our 6 pieces of tape adhered to our material, the next thing we need to do is actually remove the protective backing from each piece and then attach it to the CNC machine itself. First, let me put my stuff away. And now we'll get into removing all of the films. All right, I've got all my films removed, so this is ready to get attached to the CNC. So here we are. As we do this, there are a couple things we want to keep in mind. First of all, you can see that a lot of this, this is called a wasteboard, basically because it gets wasted as we carve into different materials. It's kind of just a sacrificial lamb that we use to allow the bit to go through the material without hitting anything that could damage it. So when we go to attach it, we want to make sure that the tape is not just hovering over nothing. We want to do our best to make sure it's actually holding onto the wasteboard in a spot. So I'm going to look for an area. I see that if I line it up kind of like this, I'll be avoiding a lot of those gaps. And another thing I want to do is we can't just throw it in at whatever angle we want, because it's going to be really hard to find this angle on the computer and lay out our design. So we want to put it in as straight as possible. So I'm being really careful, even using past Carve lines as a reference to help me line it up and lay it down. And once I do, I kind of want to just pound over where each piece of tape was and make sure that the wood is not going to go anywhere. Because again, if it starts moving while we're carving it, it's going to cause a lot of problems. So that feels really good, and we're ready for the next step. All right, our next step is going to be to choose a bit. So here are all of our tools. I'm looking for a 1/4 inch bit. 1/4 inch bit is a great default tool to use. It's very strong. You can carve pretty fast, so your project won't take forever. And just all around, it's a great tool to use, and it's pretty safe. So I'm actually going to come over back to the computer, and I am double checking that my bit is selected as a 1/4 inch solid carbide 2-flute spiral upcut. All of this is kind of gibberish. You don't really need to know what it means right now. It's just kind of details about the bit itself, kind of the way that it works. To go over it really quick, solid carbide is material. It's a special kind of metal that's hardened for cutting. 2-flute means that there are 2 blades. There's 2 tips that are actually cutting. There's 2 spirals. And upcut means that when you spin the bit, and it's always spinning clockwise, you can see that the spiral kind of moves upwards. If I spun this clockwise like this and the spiral was going the other way instead and pushing down, we would call that a down cut. But because this one goes up, you can see the spiral going up, this is an upcut. So back on the computer again, we're looking at the simulation, and I can see that not everything looks the way I want to. So my squares are coming out okay. They have slightly rounded corners because of the bit. The circle is perfect because there are no sharp corners at all. But my text has been completely eviscerated. So what I want to do in this case is see if I can't increase the size of my text. That will allow me to fit a larger bit into the shape for carving, and it should come out a little bit better. All right, so after messing with it for a little bit, I'm still not getting the results I want. So in this situation, I'm actually going to see if I can't change the font. And if even that doesn't work, then what I'm gonna wanna do is choose a different bit that is small enough to actually cut this out. But let's see if we can't just replace the text. All right, so after messing with it for a little bit and choosing a different font, I managed to find one that could be carved reasonably well with the bit that I'm using. Again, it's always an option to change your bit, but in this case, I actually want to use my 1/4 inch bit because it will also be long enough to cut through the material. If I use an 1/8 inch bit, it's a little bit scarier, so I'm going to keep my larger bit. And what I'm going to do as well is make this not quite as deep, just to speed up the process a little bit. And with that, we're ready to move on. Okay, so we know we're ready to go with our 1/4 inch bit. Our design has been calibrated for the bit that we want to use. What we need to do now is actually swap it from the bit that is currently loaded into the router. So to start, we're going to grab our wrench, and we're going to come back up to the tool, and here is how we're going to swap this out. So I'm going to set my 1/4 inch bit right here on the side, and you'll notice there is a yellow button right here. With my thumb, I'm pressing it, and it doesn't go all the way in, but if I rotate to a specific spot, you can see it fits just like that. So I'm going to take my wrench and put it onto the flat spots of the collet nut right now, and I'm going to try to loosen it by pressing. I'm trying to turn it clockwise, and it'll get loose, and then it gets tight once more
like one more time. And so we keep loosening it, and eventually the bit will fall out. Because this was an 1/8 inch bit, I'm gonna remove the whole thing because there is a Collet adapter right here on the inside. So I'm gonna press that out. Cool. So this is the adapter for 1/8 inch bits. This goes back in the drawer, along with the 1/8 inch bit. I almost forgot. So a quick note about the way that the Collet and Collet adapter works is I have an arrangement of bits here, for example, and these larger bits all have a 1/4 inch shank. You'll notice that even though they all have different tips, this is a V bit, this is a normal 1/4 inch flat end mill, ball end mill, and a taper mill. These all have the same 1/4 inch shank. So I'm gonna take those and set them to one side. And then my 1/8 inch bits over here. So on this side, you can see that we have 2 different size bits. This is an 1/8 inch bit. This is a 1/16. And even though this one is smaller, the shank is, again, the same size. So all of these bits with a 1/4 inch shank fit directly into the collet, just like that. And it holds it, and this is perfect. This can go straight up into the router. You can screw this in and you're good. But for these smaller bits, these 1/8 inch shank end mills, you'll notice that if I put them in here, it's way too big, it's not the right size, and they just fall out. So this won't work. That's why we need the collet adapter. This goes into the collet, it holds it just like that, and then you can put in your bit after that, and it'll hold it perfectly just like that. It's not exactly as tight as the original, so if I let go, it will fall out, but you can definitely see that it is closer to the right size, and there's a lot less movement. Same is true for the other 1/8 inch bit. Fits in there pretty well. And that's just like a quick little note about how the collet and collet adapters work. And now we're left with our standard 1/4 inch collet, or the router nut, some people call it, and then our 1/4 inch bit. So what I'm gonna do is load the bit all the way up. I wanna make sure that it sticks out enough to actually reach the bottom of the wood, because we're gonna be cutting this out. And I also wanna make sure that we do not go past this point right here. You can see it right where the flutes end. So it's okay to hold it here. It is not okay to go past it. So you only want to be holding the smooth part. This is called the shank of the router bit, or the end mill. So we're just holding the smooth part, and we don't want to stick out. We want to hold it as much as we can while still sticking out enough to go through. So really quick, while you guys are loading up your tools, your end mills, your bits, you want to keep in mind something called run out. Run out is how far out of the collet your end mill sticks out. So this is a long run out, this is less run out, and you want to keep this as short as you can. So I have 2 bits here. I have a very long bit and a much shorter bit. So it would be worse in this case to use this one because it sticks out so much, you can't even see it. This is gonna vibrate a lot and cause really bad quality cuts. So I'm gonna use the shortest bit that I can. And I also wanna make sure that it's able to go all the way through, stick out a little bit, and have a gap up here at the top. This is too much, so I'm gonna close it. You want about a 1/4 inch to a 3/8 of an inch gap at the top. So this is like perfect. You have your 3/8 inch gap up here, and it sticks a little bit out at the bottom. So just keep that in mind as you guys are loading up your tools. So with that in mind, I'm gonna attach this to the router again. And then once it gets tight, we're gonna use our wrench, going counterclockwise this time, and that will attach the bit securely so that we can use it for our project. In terms of tightness, you're just gonna kind of go as much as you can too. And if you're ever worried about it, you can always have somebody check. Now let's put our wrench away. And we are just about ready to start cutting. The last step to get this going is going to be to jog our machine. So back on the computer, we're gonna select the 4 arrows at the top. And let's take a quick look at our controls for jogging the machine. This just means to move the machine around. So we have an interval, which determines how far it moves every time you press the button, and these buttons to actually control the movement. So I'm gonna set the X and Y movement to 1 inch, and I'm gonna scoot it left. I'm gonna do this until I can get the bit
over this corner, this is where we're gonna set our origin. You'll notice 0, 0, that is our starting point. It's the bottom left. And if we look at our material, that's exactly here. So I'm gonna do my very best to line up the bit right over the top. And once we get close, I'm actually gonna go ahead and lower the increment so that I can get even closer without overshooting it. And I wanna be really careful moving it down because I don't wanna hit the wood.
So one trick you can do for the Z-axis is actually just take your project card and slide it under the bit. And what you're gonna do is slowly, at an interval of 0.01, lower the Z-axis while you're moving the paper. And when it stops moving, right there, that means your Z-axis is perfect. So you can go ahead, remove your paper. If you need to, you can go up a couple. Like I'll count 1, 2, 3, 4. Remove it and then go 4 down. 1, 2, 3, 4. And now my Z-axis is good to go.
You can see that the bit is right here. I'm gonna lower it until it's just right above where I want it to be, right above the wood, barely not touching. And I also wanna make sure that the center of the bit is lined up to the corner. So I'll show you what we don't want. We don't wanna do this. We don't want this because right now the outside of the bit is lined up. I want the very center lined up, which looks more like this. And then I'm gonna check the side. And that looks good. And now we are zeroed. So we've set our origin, our starting point, and now we're ready to actually close the machine up and start the job. All right, so the final step is to close the door. Make sure you latch both latches shut, and we are going to hit carve. So it's gonna ask us to confirm the material thickness and the type of material. So we've already done that. Material is secure. Remember, we taped it down, so we're good to go. We are using a 1/4 inch upcut bit, and we are gonna be using a new position. The next step is to raise the bit. We're gonna wanna come over to the side and turn on the spindle. That's by flipping this switch forward. And with the spindle on, we can carve. We're gonna go ahead and let this thing finish. It's always a good idea while this machine is running. In fact, it's a requirement. You need to stay in the area so that you can hear it. If anything sounds weird, you wanna be there and be ready to shut off the machine by hitting the emergency stop on the side. So just stay nearby the machine until the project is done. And when this is finished up, we'll come back and we'll take it out. All right, so the machine just finished. As you can see, the spindle is still going, so we're gonna wanna turn that off. So with the spindle off, what we're gonna do is we can actually open the door. So I'm gonna unlatch it. You do wanna be really careful. This is going to rain down dust and chips. So we're gonna open it as gently as we can. It is pretty high, so if your arm isn't long enough, you can grab the side of the door and let it come up slowly. And you will, of course, still get dust on yourself. So we head over back to Easel. We can kind of take a look at our project and say, yes, that looks great. Review cut settings. Okay, we're gonna close it. We're gonna go back to the jogging control. The first thing I wanna do is raise the Z up by at least 1 inch to make sure it's clear of anything that it could hit. And then we're gonna increase the interval for the X and Y. We're gonna scoot it over. And with everything cleared out of the way, now we're gonna go ahead and I'm gonna vacuum all this up as well as the door, like the inside of the door. That way we're clean before we move on to remove the part. All right, so as you can see, it doesn't have to be pristine. There's still a little bit of dust and chips in different places, but we just want it to be kind of as clean as we can get for where it is right now. And Now that everything is like pretty clean, we can go ahead and try to remove our part. All right, so my phone died while I was shooting the last clip, but basically all we need to do to remove our part is to slide the wrench underneath, pry upwards, and then you can remove it. I've already taken the tape off, but you can just roll it off or peel it, whatever's easiest, and then you have your finished part. And so once this is removed, you can go ahead, just clean up any other dust that might be in there. If you have tools, put them away, and that is it. So with our part removed and finished, we're essentially done. So just make sure things are cleaned up. Go ahead and close the door. You can latch it shut. And then just go ahead and close out of any windows that might be open still. And the very last thing we can do is go ahead and smack the emergency stop to shut off the unit. Cool, that's it for this video. Thanks for watching.